What's up you guys, welcome back. Now in this video we are going to be working on sketching graphs. Okay, we'll learn how to sketch trigonometric graphs. So there are three types of graph you have to learn. First is sine, then cos, and then tangent. So how do you sketch? Say, let me give you an example. So let's say we got your x-axis, y-axis. So a sine graph looks like this. Okay, this is a sine graph. Start from 0. Here will be 360, one full cycle, right? So it's 360. Here will be 180. Okay, up here will be your y, and then here will be your x. Okay, so now here is up to you lah. If you want to label here 90 also can, here 270 also can. Okay, it's up to you. So this is what a sine graph looks like. So y equals to sine x. So this is how the graph looks like. Next, what about cosine? See, cosine is actually the same as sine, but the only difference is you are taking different part of the graph. So you all know that sine is like this, right? So if I extend the line, if I continue doing another cycle, it will look like this, correct? There's a second cycle. So where is the cos graph? Cos graph is here. It's just different part of the sine graph. Okay, it's actually the same sine graph, but it's different part. So when you sketch the cos graph, it looks like this. Okay, it's just like this. It's just different part of the sine graph. So here again y, here x. So here would be your full cycle. So here is 360. Here would be 180. Okay, you want to label the 90, 270 is also okay, but I won't lah. Okay, but anyway, here, by the way, I forgot to tell you, this thing here is what we call as the amplitude, the height of the graph. So the height of the graph, if you notice, this is just sine x, right? The amplitude is, what's the front here? The front here, whatever number it is, that determines the amplitude. So in this case, there is nothing written there, so it's actually 1. So here is 1, -1, same as the cos. Here is 1, and then here is -1. So this graph is y equals to cos x. Clear? So this is how you draw your sine and cos graph. Now, tangent graph is completely different. Okay, tangent graph, let me show you. So I'm going to draw here. Oops, sorry, let me change color. Okay, tangent graph is a bit different. See, tangent graph starts from here. Okay, and then this is what we call as the asymptote. Okay, the line will never touch the asymptote. Okay, so it comes here again, another line. Here is another asymptote. Then here. Okay, this is a tangent graph. So this here will be y, here will be x. This is y equals to tangent x. Okay, so same thing, full cycle here will be 360. Here will be 180. The asymptote here, these two would be 90 and 270, but I won't label lah. Okay, so if you notice, if you key in your calculator, right, you notice that if you type in tangent 90 or tangent 270, you will get math error. The reason is because this is why we call this as the asymptote. This part 90 and 270, the tangent line, the graph, will never touch the asymptote, will never touch this part. So that's why when you key in your calculator, it's written as math error because it doesn't exist. Okay, alright, so this is how you draw the tangent graph. So this is the basic lah. Now I'm going to go through some different type, okay, how the question can ask you. The question, of course, is not going to give you this draw sine x, draw cos x, you know, it's not going to give you so simple. So what you can do is, okay, give you an example. Let's say y equals to negative sine x. Okay, so you already know that sine x is like this, correct? This is sine graph. Now you have negative. So what the negative does is, the negative will turn the positive side into negative and the negative side into positive. So what happens is it becomes like this. So originally the positive side now becomes the negative side, and the negative side becomes the positive side. So this is what the negative does. Okay, the amplitude still the same. Amplitude here is still 1, negative 1. Up here is y, here is x. Okay, this one don't change. And then here is 180, here is 360. Okay, by the way, this one is in degree. If the question give you in radian, you can change the 180 to, see here, let me just draw again. Okay, this is a sine graph, so we always label here as 180, here is 360, correct? If the question asks you in terms of pi, okay, that means in radian form, here would be 2 pi, here would be pi. Okay, hope you also remember this. So here would be 1 over 2 pi, this would be 3 over 2 pi. Okay, so it just depends whether you want in radian or you want in degree. Okay, so we have already done negative, so it applies to all. So if let's say you have a cos graph and then you get now negative cos x, so you have to invert it, it becomes like this. Okay, if you got a tangent graph, tangent I already showed you is like this, right? So if you have a negative tangent, then the positive side will come negative, it becomes like this. Okay, something like that lah. Okay, I'm just sketching to show you all. Okay, have the idea first, later on we'll do practice, then you'll understand. Okay, so this is the first type, which is negative. Now what if the question give you like this, y equals to 3 sine x. So I told you all before, the front number tells you the amplitude. Okay, the amplitude, that means the height of the graph. So if normal sine x, it's like this, correct? It's like this, and then here is 1, here is negative 1. But in this case, now the amplitude is different. Amplitude is going to be 3, negative 3. Okay, because now it's stated here 3. Okay, so that is the purpose of the number in front, and it applies to all the other graph. I'm just using sine as a reference. Okay, you apply the same thing for cos and tangent. Next, what if the question asks you y equals to sine 2x? Now the number is behind. So this, if the number is behind, it tells you the number of cycle within the number of cycle within the 360 degree. Okay, so in other words, you see, when we do sine x, that means there's only one cycle within the 360. So here, one cycle, this is 360, 180, correct? But if it's 2x, that means there are 2 cycles within the 360. So it looks like this. One cycle and another cycle. Okay, so extend this, and then here is x, here is y. Okay, and then now this one here becomes 360. So now your 180 comes here. Here would be your 90. Here would be your 270. Okay, that means the 2x means 2 cycles. Okay, 2 cycles within the 360 degree. Okay, so that's the purpose of the number there. Same thing applies to cos and tangent. If it's 2x, that means you have to draw twice within the 360. Alright, next, what if you have y equals to modulus sine x? So we learned this in the past, right? Modulus does what? Now modulus changes all the negative value into positive value. Okay, so if I tell you negative 1 modulus, you get positive. If it's already positive, then no change, you still get 1. Okay, so basically whatever that is negative will be changed to positive, and whatever that is positive will remain the same. So it looks like this. So originally it's like that, right? Sine graph. So this one is already in positive side. Here the negative will have to change to positive, so it looks like this. Okay, so here is still 1. Here is y, here is x, 360, here is 180. Okay, so that is how you do it. All the negative side change to positive. Same thing applies to cos and tangent as well. Okay, no worries, later we'll do exercises, you'll understand. And what else? So what if they ask like this, y equals to negative modulus phi sine 2x. Now I combine everything, negative modulus phi sine 2x. So let us do step by step. Okay, so originally sine x is like this, correct? Now they want sine 2x, so you have 2 cycles. Okay, and then because it is 5 here, so the amplitude is going to be 5 and negative 5, correct? Now they have modulus, so modulus means all the negative part will change to positive, so it becomes like this, here and here. Okay, so there is no more bottom one here anymore. Okay, something like that. And then you have the negative now, so that means whatever that is positive will change to negative, and whatever is negative will change to positive. It's like invert it, so you invert it, it becomes the bottom. Understand? So there's no more top one. So this is what we call as this graph lah. Okay, so let us draw this again. So it looks like this: 1, 2, 3, 4. Okay, here is y, here is x, this is 180, this is 360. Don't forget to label the amplitude. So this is negative 5 because it's at the bottom, okay, below 0, so it's negative 5. There is no more top anymore lah, because the modulus makes it become positive, and then the negative inverts it to negative. So there is no negative part of there's no positive part of the graph. Okay, wait, let me erase this. Yeah, so basically this is more or less most of the type of question lah they can ask. So of course the question not going to ask so simple. They will sort of like apply a few of this into one question, so you must know what to do when you see the question. Oh wait, one more I forgot to add. A very simple one is, what if they give you something like this: y equals to sine x plus 2. So now you got plus 2 behind. What the plus 2 means is you are shifting the graph on top. Okay, if it's plus 2, that means you shift the graph on top. If it's negative 2, you shift the graph down. Negative means down, positive means up. Okay, by 2 units lah. Plus 2 means 2 units. If it's plus 3, then 3 units. Okay, so I give you an example. So let's say your original graph is like this: sine x, y equals sine x. So here is 1, here is 0, and then here is negative 1, correct? So now you're going to shift this plus 2, that means you're going to shift the graph up by 2 units. So now the starting line is not going to be on 0 anymore, it's going to be on 2, right? So wait, let me extend here. So from 0, now you plus 2, so it goes to 2. So it starts from here. Okay, so here would be originally it was 1, so you plus 2 becomes 3. So here is 3, and then this part here will be, here should be 1 lah. So should be 1, because negative 1 plus 2, right? So it becomes 0 and then 1. So this is your new position of the graph. Clear? So let me sketch this for you. Here is x, here is y, here is 2, so your graph looks like this. That is 2, here should be 1, and then here should be 3. Okay, so yeah, and then you can label here would be 360, halfway here would be 180. So this graph is y equals to sine x plus 2. Clear? So let me recap. If it's plus 2, that means you're shifting up. If it's negative 2, you're shifting down. Okay, negative means shift down. Alright, so yeah, this is the basics of sketching graph. So now let us go straight to some exercises. Alright guys, let's sketch this together. So they said draw the following graphs for, okay, so first one, they give you y equals to sine 2x. So let us recap. Sine x will give you like this, correct? Sine 2x, that means there are 2 cycles. Okay, 2x, that means got 2 cycles. Okay, now originally the amplitude is 1 and negative 1, correct? Because here is 1, so it's 1, negative 1. But in this case, they gave you the amplitude is 1 over 2. So now your amplitude here is 1 over 2 and negative 1 over 2. Okay, so that's how your graph will look like. So let us sketch together. So it will look like this. One cycle, this sine graph, this is the basic sine graph, and then another cycle. Okay, so here will be x, here will be y. So this one here will be 360 degree, here will be 180 degree. Then you can plot your 90 or so, here 90, here 270. And then the amplitude, don't forget, amplitude is 1 over 2 and negative 1 over 2. Clear? So this is the first graph. Next, they want cos graph now. So the graph is y equals to 2 minus cos x. So again, cos x is like this. It's like a smiley. Okay, it's just different part of the sine graph. And then negative means you are inverting the graph, so you flip it, so it becomes like this. Okay, this is the negative cos x. Now you got 2. So I told you, if the 2, this is not amplitude, this is you're shifting the graph, because it's positive 2, right? Positive 2. So originally it's like this. Now you're going to shift the graph to the top by 2 units. Okay, so originally it's here 0, here negative 1, here is 1. So you're going to plus 2 for each of them. So negative 1 will end up here at 1, and then the 0 plus 2 you end up at, there's 1 here, 0, 2. Okay, extend the graph, and then the 1 will be at 3. So your new graph will look like this. Sorry, I'm just sketching. I hope you all understand this. Okay, that means I'm shifting the graph. Originally is here. This is the original one, and then I'm going to shift by 2 units. Okay, so this is how your new graph is going to look like. So let me sketch this. Okay, so now it's going to start at 1. The middle would be 2, and then here is 3. So the graph is looking like this. Oh my god, so bad at drawing this. Give me a minute here, guys. Something like that lah. Okay, so here would be the middle. Here is 1, here is the amplitude. The height is 1 unit lah, so it's 3 there. Okay, so here is the middle. So here will be 180. Here is 360. Okay, so here is x, here is y. Okay, and then you can of course label the graph lah. So this is y, first one is y equals to 1 over 2 sine 2x. This graph will be y equals to 2 minus cos x. Okay, now the third part is tangent. Okay, wait, let me erase this. So tangent, let's see. Okay, I draw this bigger lah, then you all can see. So tangent, see, I told you all tangent is how, like this. Asymptote here, asymptote. Okay, this is just one full cycle of tangent graph. Now you have tangent 2x, tangent 2x, so you must continue another cycle. Okay, wait, I have no space, but it's something like this lah. Okay, another extra 2 cycles, and then you're going to have negative. So negative means you're going to invert this. So when you invert, it's going to look like this. The top one will go to the bottom, bottom one will go to the top, then here would be like this, but then you got 2 cycles, so here 1, 2, 3. Okay, and then you have to plus 1, so now you have to shift everything by 1, so it looks like this. Okay, I straight away draw. So originally is you start at 0, but now you shift up by 1, right? Plus 1, so you're going to start at 1. Okay, so it's going to look like this here. Then this is the asymptote. Then here, okay, asymptote again, another one. So this is one complete cycle technically, but now you got 2 cycles, so you have to continue. Again, asymptote, again asymptote. Sorry, I need to erase this, I got no space. Just one more extra line, then we are done. Then here would be, okay, that's it. Okay, extend this line. Here is x, here is y. Now we can label. So here would be 360. So halfway is where? Halfway is here, 180. Okay, so halfway here you have to be 180, and then you want to label your 90 degree, 270 is up to you. Okay, but I'll just leave it like this. So here will be your y, here will be your x, and then the graph, please label. The graph would be y equals to negative tangent 2x plus 1. So 2x means 2 cycles, so that's what we did here. And then negative means you invert it from positive to negative, negative to positive. Okay, that means you flip the graph. And then plus 1 means you shift the graph to the top, okay, by 1 unit. So this is how the graph looks like. Alright, next, sketch the graph of the function y equals to negative. Okay, so this one, see here, you got the amplitude, you got modulus, and you got 2 cycles, and then you must plus 1. So let us do this step by step. Sine x would be like this, correct? So if sine 2x is going to be 2 cycles. Okay, it's unclear so far. Now you got modulus 2x. So modulus means whatever that is on the negative side will become positive. So your graph looks like this. 1, 2, 3, 4. Okay, that means negative all become positive, and then the positive will remain at positive, so it becomes like this. Then you have the amplitude now is 2. Okay, the 2 would be here, and then you have negative, so you have to flip it, so it becomes negative. So it goes to the negative side now. Okay, negative side, and then you have to plus 1. So now when you plus 1, you have to shift everything by 1 unit. So let us straight away draw this. Okay, draw your axis first. Okay, so now it goes up by 1 unit. So starting here is 0, here would be -2, right? Because the amplitude is 2 just now. So -2. So when you plus 1, the -2 becomes -1. So here -1. Then originally you start at 0, but now you plus 1, it becomes 1. So that means you're starting at 1 now. Okay, so your graph will look like this. Wait, this is the starting, this is the ending. 1, 2, 3, 4, something like this. Okay, yeah, so label, this will be your y, here will be your x, here would be 360. Sorry, you cannot use 360 because they say this is 2 pi and 0. That means they are labeling it in terms of radian. Okay, so here is 2 pi, so halfway is here, right? So here is pi, and then you can label, here will be 1/2 pi, and then here will be 3/2 pi. Also can. Okay, you don't want to label, also fine lah. Just make sure the pi and 2 pi is there. And yeah, that's about it, I guess. There's nothing else to label anymore. So of course, write your graph. Y equals to -2 modulus sine 2x plus 1. Okay, this is how your graph should look like. Clear? Right, next. Okay, so now there are more than one graph. Okay, we're going to sketch more than one graph. So they say sketch the graph y equals to 3 sine 2x for this range 0 to 2 pi. Then on the same axis, draw a suitable straight line to find the number of solution. Number of solution means how many intersection there. Okay, how many intersection between the two graphs. So number of solution for the equation, this one. Okay, so there's another equation. So how are you going to solve this? Okay, first we have to plot this graph. Okay, plot it first. So y equals to 3 sine 2x. So 2x means 2 cycle, and then the amplitude is 3. Okay, so let me erase this first. So it looks like this. 2 cycles, they said 2x, so it's 1 and 2. Okay, this is 2 cycles. Here's x, here's y. Here would be 2 pi, here would be pi. The amplitude would be, see the amplitude they gave you 3, right? So it's 3 and -3. Okay, so now this is how the graph should look like. Now they give you this equation, so you have to find the other graph. So here is 3 pi sine 2x plus 2x. Oh wait, let me no space there. 3 pi sine 2x plus 2x equals to 3 pi. Okay, so now we try to make one side of the equation become like the original equation here. Okay, the original equation of this graph is y equals to 3 sine 2x. Correct? So how are we going to make this become this 3 sine 2x? So you have to remove what? You can remove the 2x first. Okay, remove this. So it becomes 3 pi sine 2x equals to 3 pi minus 2x. Okay, and then you want to remove the pi. So you remove the pi, that means the whole thing you divide by pi. Okay, so when you divide by pi, you get 3 sine 2x on the left hand side. Right hand side will be 3 pi over pi minus 2x over pi. So here you can cancel. So 3 sine 2x is equals to y, right? 3 sine 2x equals to y. So that means y is equals to 3 minus 2x over pi. Okay, so this is your new equation, the second equation that you're going to use to plot your graph on this, okay, to sketch your graph on together with this graph. Okay, so now question is, what kind of graph is this? So if you notice, this is actually a straight line graph. Remember, y equals to, here got one x, right? If I write the x here, see, if I write the x down here, it becomes y equals to mx plus c. The c is in front. Okay, the c is 3, and then the x is here. The gradient is negative 2 over pi. So it's actually a straight line. Okay, and just by looking at this, you know it's a downward line. How you know it's a downward line? Because it's a negative gradient. The m is negative 2 over pi. So it's a negative gradient. So you know the line is going to go down. So let's draw this together, okay? So you know that the y-intercept is 3. So you can start with here. So you start with the y-intercept here. And then you want to find another point. So let's say, let's see, we used pi, okay? So if x is equals to pi, what would be the y value? So y equals to 3 minus 2 over pi times x is pi, right? So cut. So 3 minus 2 equals to 1. So that means when x is equals to pi, your y value equals to 1. So let's say 1 is somewhere here. Okay, so let's say 1 is somewhere here. So this is your line, that is your cross. Then you can, sorry because I'm just using freehand, but it should look something like this. Cross that line. Okay, something like this lah. Wait, yeah, I cannot draw exact, but yeah, something like this. Okay, so this line here would be y equals to 3 minus 2 over pi x. Okay, this is the equation of the second line. Clear? Now you want to find the number of solutions. So number of solution means how many how many intersection, okay, between the two graphs. Okay, so first you get 1 here, 2 here, 3, 4 and 5. Okay, so there are 5 intersections. So the number of solution would be 5. Okay, number of solution means how many intersection lah. Clear? So let's see the next one. By sketching the graph y equals to, okay, so they give you the equation. Find the range of value k such that this 2 equation here has no real root. Okay, so let's do this together. They give you the graph y equals to 3 plus modulus cos x. So cos you already know, it's like this. Modulus means the negative part will become positive, so the graph looks like this. Okay, there is no longer negative side because modulus change it to positive. And then you have plus 3, right? Wait, let me just write here. So this is modulus cos x. Now plus 3, that means here is originally 1, here originally 0. You're going to shift the whole graph by 3 units, shift to the top. Okay, 3 units to the top. So let me just sketch the graph for you. So originally is at 0 and 1, correct? So if you shift 3 units to the top, it becomes what? 3 and, let's say 3 is here. 1, 2, 3. Okay, no, let me draw the graph bigger, then easier to sketch later. Okay. Okay, let's say 1, 2, 3 and 4. Okay, 4 is up here. this is 4, this is 3. Okay, so now it looks like this. Okay, something like this lah. Okay, this is the 4. Okay, then here you can label. If you want to label, you can label lah. So here is 2 pi. Here is pi, and then 1 over 2 pi you can label, or you don't want also can. Okay, here is x. Yeah, so this is your graph for this y equals to 3 plus modulus cos x. Okay, so now we have to find the other graph, because they gave you the equation there, right? They asked you to find the value of k. So you see the equation they gave you is modulus cos x equals to k minus 3. So how can we change this equation to become like this? So what we can do is we can change the negative 3, bring it there, correct? So it becomes 3 plus modulus cos x equals to k. So this is equals to y, right? So y equals to k. So if you get a y equals to k, how would your equation be? Your equation will be a flat line, right? Like this, or can be here, can be here. Okay, it's a flat line. So if I tell you y equals to 1, so your equation is, the line is here, because here is 1, right? It's a flat line. Okay, that's the y equation. So now they say y is equals to k, so you know it's going to be a flat line. And they say that it has no real roots. So this one you learn in form 1, right? No, sorry, not form 1, form 4. No real roots. That means there is no intersection, right? That means the line does not cut through the graph, the existing graph here. That's why there is no real root. If you cut one, that means there is real root. Okay, but in this case they said there is no real root. That means there is no intersection at all. So where do you think the k value should be to have no real root? It should be above 4, anywhere above 4. It can be anywhere up here, or it can be anywhere down here, correct? Because above 4 and below 3 you won't have any intersection. So in other words, they ask you to find what? The range of k such that this equation has no real root. So in other words, the k value should either be more than 3 and more than 4, or k less than 3. That means it's either down here or up here. Okay, so I hope you guys understand this. So this will be your answer. K is either more than 4 or k is less than 3. Okay, so this is your answer. So that is all actually for our graph. I hope these few exercises help you understand how to sketch your graph. Of course, there will also be drawing graphs where you have to use a proper scale, but I'm just teaching you a way of sketching. Okay, the drawing part you can use your own scale and do your own table to find out the actual graph. Okay, so this is how you sketch graph. So I hope you find this useful, and I hope to see you all in my part 3 video. Okay, so take care and bye bye.